Welcome back. And if you're joining live, thanks for joining. And if you're coming back for a stream at a later stage, welcome to my last official video of my RatRig build. When I say last official, I don't mean that there will be no more RatRig modifications, but as part of the build series, I think that's where I'm going to call it a day, because we're printing. We're having a great time printing. We've done a lot of experiments. Unfortunately, it's been quite some time since I've streamed. Life got busy, and a lot of things have happened in the meantime. And yeah, we're pretty much at the end of the build for what I initially intended. So today in this stream, my intention is just to wrap up a lot of the items that we sort of touched on, but we didn't even really finished. Show you some more of the printer, what we've done in terms of the finishing pieces, and then I'm going to close off some of the back of it together with you in the stream, and I'm going to call it a day for the official build. As I say, I'm looking forward to doing some modifications, but these will come down the road probably in about a month or two's time. So yeah, good to get going back. Yeah, this will be also the last official time I'm actually streaming from this house, as we're about to move. And so with that move will come a bit of time before I actually get back onto streaming and getting everything up and running again. But that's opportunity to move my machine around and get some other machines up and running again. My Voron on the side here needs some TLC, so it'll come into one of my streams soon. I'm actually going to do a complete revamp, same way that I built the RatRig. I'm going to do all the bells and whistles on it, meaning fully automated, and you'll see that tonight as well on this build. So welcome to those here. Terry, welcome. Tyron, good to see you again. Haven't seen you for quite some time. Glad you're joining. And France, as usual, hello. Always there, always looking. If you're on the stream, on the live stream, say hi in the chat so that I can see who's there. And yeah, ask questions. Ask questions how the build went. Ask anything you want. I think as much as what my intention was to show people and teach people a lot about what happens in a build like this, there is a lot of experience, a lot of things that I've learned along the way. By trial and error, working with the RatRig team, going with the RatOS guys, Mikhail and them, having a bit of a fight with them as well, having a bit of a fight with RatRig as well, but all ends well. You know, we've solved all the issues. We've got to a place where I must say I'm very happy with the machine. I'm actually very excited to use the machine. It works so well. And yes, someone else that yes, someone that has come onto the stream that's actually we've been talking on Discord and exchanging a lot. He's also building a RatRig, so I'm now going to try and pronounce your name. I know it's Polish, I think. Matuis, something like that. I know him as Matos165. That's what I know him as on Discord. But we've been working together quite a bit, and I'm actually quite excited to see what he's going to be doing with his printer as well. Going through the same challenges as I am, bed leveling, getting RatRig to support us on some of the items that we've been very upset about. But yeah, it's been an amazing journey. Okay, so my dad's also there. Hi, Dad. Good to see you on as well. I think you've also missed the streams. I think he enjoys it the most, just sitting back and relaxing and watching the build. I think he's looking more forward to coming to visit us so that he can actually see the machine in real time. Okay, so I think in the last build we actually got to the point where we did the bed mesh with a beacon probe, and that is where we stopped. We also did a very small print, just to see the printer printing and make sure it's printing. I can tell you, in the meantime, we have pushed some large prints through this printer. It's now my official trash can, right? But I had to print something big to try. And then we've also done some exciting smaller prints. Let me grab these two. Yeah, let me show you these. So this is a dolphin skull with the teeth and everything. So we've done these. Hi Julio, long time as well. Welcome back. We've done a sea otter skull for some tests as well. So yeah, the printer's really doing well. And I think what's more exciting is these are PLA prints, but I'm also been doing ASA prints, and so a lot of ASA prints with full threads designed, and I'm going to I'll put it into the link a little bit later, or maybe yeah, let me put it there now. I've just recently launched my website as well, and we're starting to do print on demand, you know, for requests for people that want to print or need prototyping done, and also if there's any production and a bit of CAD design, we're going to start doing that as well from this side, as a adventure that I'd like to take on, something that I think I will enjoy very much and hope to make it a permanent career one day. I hope I've got it right there. Does that work when I click on it? Yeah, it should work. Right, so, and I'll just quickly open it up on my top screen here so I can show you. Sorry, I'm having to lean over to the keyboard to get to the keyboard because I kept my table a bit free tonight. Let's see if it'll open there. And we can do that one. So, welcome to Desert Sands 3D. As we initially started the channel, this is the new website, new logo, bit of a new touch, bragging a little bit about the printer itself, and we're introducing different concepts of the printing to the people, and we're also saying that we can do some CAD drawings. Yeah, very simple site, but it's enough to get us going. In the gallery, we've included some of our CAD drawings that we've done, and part of them are on this printer, you know, and some of them are on my camping equipment, and then also some of the other projects that we've been printing. We've been doing some castles for the people that play board games. I'll just pull up that one so you can see it's quite a nice printout, all done on this. Tonight we will be discussing this. I printed a bento carbon filter for this printer because printing with ASA and ABS is not the best on the lungs. So I printed the filter, and I'm actually busy going to connect it up, and I'm actually going to try on this stream get it up and running with the motors and fully automated during an ASA print. Maybe I won't do it totally in this print, but at least you'll see the filter in action, and we'll take it from there. Further to that, just a little bit more about the printers. Yeah, and then if anybody ever needs to get hold of us, they can get click the Get in Touch button, and that'll send us a mail. And myself and France standing there trying to look our most intelligent while taking a photo for the website. So yeah, that's just a little bit about what we've achieved as well in the meantime. And I've seen some interest in people actually wanting to print and wanting to come and have some designs, and so I'm pretty hopeful that will kick off and go well. I just want to drop a message in a group. There we go. That's it. Otherwise, I'm going to get bothered the whole time. Okay, let's get to the printer. Where should we start? Let's start off with maybe having a look. So this is what the printer looks like. Still not all clipped up, but the fan will go in. We're going to tighten that now. I was just working on one of the new wires at the back here. In actual fact, I'm going to this is for the fan, the bento, the carbon filter inside the printer. Maybe if I use the side, no, you can't see it. That's a horrible picture. Where am I pointing my camera at? Let's have a look. Let's bring it back into scope. Right, so that should give you roughly a view of what's happening inside the printer. And there you can see the filter standing in the background. And let me just lift it up a little bit. With the two PTC heaters that heat the chamber up. That fan has got a wire coming through to the back here, and that's what I was connecting tonight. Let me just switch to that only, and you can see that part of this filter, it's multiple stages. So you've got your bottom, that is just your fan sucking air through the bottom. The next portion is your carbon filter, and I'll show that to you now. When I connect it, it's got a magazine with carbon, and the top one is a HEPA filter, right? And it's all held together by magnets and just clips in like that. Pretty neat, and should at least give me quite a bit of ventilation, circulation of air through the printer, and pull some of those nasty VOCs out of the air, and hopefully keep my lungs and the family's lungs a little bit healthier as we go along. So that's one of the things that I was doing tonight, and I'm going to finish that off now with you. I just want to we're going to change one wire, and once we've changed that wire, I'm going to go into the software and see if we can configure that. Going into the configuration, I've never ever shown you how I configured my PTC heaters, so I will just step back on that and go to recap that slightly so that you can see that, and how those were configured to run as well inside the RatRig printer file, the printer CFG file. So let me go to quickly, and because I was probably in a bit of a rush earlier, I connected this wire incorrectly. That's why I had to pull it out over here, and it's still hanging over here, because now the fan comes on permanently instead of only when I need power. So I'm just going to move the one wire across from the 24 volt permanently to a signal pin, so that I can then control it, and then I'll give you a bit of I'll explain it now on the documentation. Like that. Right. Just plug it back in. Okay. At least now I can hear the fans on coming on. So let's go to the main screen here, and we can have a look at the configuration. Maybe before we do that, let's come back first one more thing. So we've got the SSRs here, which one of them you would have seen in the videos we would have connected to the bed, because it's an AC bed. So we use the SSR to control the AC voltage to the bed. And obviously that's connected to the main controller. In the same way, the PTC heaters inside the chamber are exactly the same concept. And so we have to control the AC voltage to those PTC heaters. Now I went with AC PTC heaters because I wanted a little bit of a higher wattage, fan and pulling a lower amperage, and I thought the AC would work better, and so far it's been quite good. So because they're AC PTC heaters, I also have to control them via SSR. So in the same concept that I've connected the bed, I've connected up a SSR to the two fans, and the fans are then connected to one of the heater channels. Now if I go to the board layout, maybe not that one, let's do that. Just to come back to the screen, and then I can show you on the screen. Okay, so if you have a look again, we have our heater channels over here, and typically these are used for the heater elements on your extruder, but because my extruder is connected to a tool board, I'm not using these heater elements in the same manner. So in order to connect my heater, my chamber heater, I connected it, and I'm now going to have to talk under correction here. I think I connected it to heater number 1 or 2. We'll have a look now. In any case, I connected it to one of these two heaters, and I was able to control the heater element, the chamber heater with that heater element, right? Then in terms of the fan that I'm connecting, fan number 6 over here, this 4-pin fan over here is actually connected to my controller fan, right? The fan that's on the keeping the controller cool. Fan number 5 is keeping the Raspberry Pi cool, and I will now use this fan 4 to actually use that as the circulation controller for the filter, carbon filter that I've got inside. Obviously there's 2 fans inside that filter. I cannot take both fans taco wire and connect it up, so I'm only going to be measuring the speed of one of the fans, but the voltage is going to both the fans in parallel, so I know I'm sending the same voltage, so therefore hopefully the fans are roughly the same speed. But again, I'm not too worried about the speed of the fan, because you're either going to have it 100% on or 100% off. So the taco wire is actually just for interest sake to see what speed the fan's turning at. Okay, going to the printer and going into the configuration. I'll just scroll down here quickly and get to the point where we last stopped off. So last we stopped off when we had done the bed mesh. Over here I've created the chamber heater, okay, and I'm using a generic heater controller, right, and I called it chamber heater, and you'll see the header pin is PA0, right, PA0, and the sensor pin is PA, for the temperature is PA7. So if we go back to this document, PA0, there's my heater element. I'm using heater element number 1, right? And for my temperature sensor, I'm using, thank you. I am using, which one did I say I was going to be using? I've got PA7. Let's see. PA7. So I'm using thermistor number 3, right? I'm using thermistor number 3 to measure the temperature. Now I've got 2 thermistors in, and maybe I'm going to try quickly and show you those 2. I'll move my camera slightly. Over here you can see one of the thermistors sticking out, right? I've got 2. I've got one in the middle of the chamber, and then one at the top of the chamber. So let me see if I just point that up slightly, although from a light perspective we're not seeing much. Maybe I should switch on the printer lights a little bit. Give me a moment, maybe that'll help us see better inside. You close that one, or wait, let me just open up another one. And then I can take the chamber light and just bring it up. Yeah, you're not going to totally see it. In any case, I'll show you a little bit. I'll have to show that a bit later, because it's slightly hidden away there. There's no reason why I can't do this. Okay, let me just. What you would have now, as soon as I started homing, you would have seen this fan came on and this fan came on. Because the motors are turning, it knows that the main board's drivers are working and the Raspberry Pi is working, so it automatically starts cooling it down. I'm just going to try and get this thing to home and get out of the way slightly. Alright, so now let's go back to the side and see if we can see it. Very difficult to see, but I will try and point this camera just slightly this way. So there is one of the temperature sensors and there is one of the other temperature sensors. Now this temperature sensor at the top, that's the one that I'm actually using to measure the bed, the actual chamber heat. The one in the middle is just for my knowledge, just to see what the differentiation in heat is in the top of the chamber and the bottom of the chamber. Obviously, naturally, as the hot air rises, it sits at the top, and then the chamber gets warm, and as it gets warm, the heat goes down slowly. So eventually, the middle, even though the hot air is coming from the bottom and it's going up pretty fast, the middle of the chamber will heat up eventually. And so as the print comes down, it should, in theory, remain within the same heat temperature all the way throughout the print. At least that's what we're trying to do. Okay. So far, I haven't done a big enough print with ASA or ABS to actually test that, but it seems like that's what's going to be happening. So let's go back to the configuration. So in our config, we created a chamber heater setting. Heater pin, max power is 100%, generic type sensor. We connected it to our thermistor number 3, and then we had to decide as to what type of control we want to use to manage the heaters switching on and off of the PTC heater. Now, something that I initially did was, if I go a little bit further up, you can see you can do a PID control, right? The bed is controlled by a PID, which basically pulse emulates the heat on the bed to try and keep the bed as stable as possible. It knows when to switch on, when to switch off, and it also predicts and it limits the voltage to the bed as well. Unfortunately, that didn't work very well with PTC heaters. The PTC heaters didn't like the variation in temperature, and even though it was trying to vary the temperature, it wasn't able to heat the chamber. So I had to go back to what we call watermark. Pretty much, that's the temperature. When it hits that temperature, switch on, switch off, and when it drops below a certain temperature, switch on at max power. And I just gave it the minimum temperature it's allowed to be and the maximum temperature. Okay. The next thing that came along was, even though I was running the heaters, the machine kept switching off and saying expected temperature climb not recognized. In other words, it wasn't heating up the chamber fast enough for the temperature sensor to notice a change, and a big enough change. And because of safety features built into Clipper, it would put the machine into fail mode and the whole system would shut down the whole time. So I had to, on the chamber heater itself, add what we call a verify heater section. which then allowed me to play with these settings. I'm not going to go through them in detail. You can read up about them because I think everybody's chamber is going to be slightly different. But essentially what I've done is I've told the heater, I think this was 60 and I think this was 120. I said to it, listen, give it more time to heat and expect the temperature rise to be a little bit slower. And it was eventually happy. It's still got a fail safe, so if I open up the door, the chamber door, and it tries to heat the temperature, read the sensor, what will happen is the whole chamber heat will drop very quickly. And because the heat drops so quickly in the chamber, it will realize it's a mistake and it puts the whole machine into a fail safe mode and shuts down everything. So it works for overheat and if it suddenly loses heat in both directions, it will compensate for the volume of air that I'm trying to warm up. Then, as I said, I have a middle sensor, and that middle sensor is just for my knowledge as to what's happening. So if I go back to the main screen over here, you will see in my chamber heater at the moment, the top one, state is off because it's not doing anything, it's not heating, it's at about 24.6 degrees, and the bottom sensor is about 24.1, right? And that's just giving me an indication as to what the middle of the chamber is. In the same way, I created a temperature sensor, just a plain sensor now because there's no heater element connected to it, and I connected it to PC4. If you want to see where PC4 was, PC4 is thermostat number 2, right, which is that one over there, and I connected my wires to that just to do the sensing. And yeah, that was it. Just gave it minimum max temperature, and so now I can see the temperature top and bottom, and I can control the temperature inside. Now I'm going to go one step further, and I'm going to skip some of these sections, and I'm going to come up to this, which is a macro that is in the original file. Now, in the original MratOS files, this macro exists in the macro file. You're not allowed to change anything inside the original macro file. So what you do is you copy that whole section, you bring it to this file, you paste it into this area, and because this is executing after the original macro file, whatever is inside here overwrites the previous configuration, right? So it will always use this as the actual macro. And inside this macro, all that we're doing is we're just telling it to set the temperature heater, chamber heater to the temperature that's coming in from the slicer via the G-code file. The G-code carries a parameter called chamber heater. It sets the chamber heater called chamber heater. Right? It sets the heater called chamber heater. I'm getting my tongue all twisted. It sets the heater called chamber heater to a target temperature, which is a parameter that came in under chamber temp from your G-code file, from your slicer, and you pass that inside. So I think what I need to actually do is to show you the full circle there. I'm using Orca Slicer, so I'm going to bring Orca Slicer into the screen in a minute. Let me just start it up. All right, Orca Slicer. So inside my Orca Slicer, I have my printer set up, right? And I'm going to pull this a little bit like that because it's... And here's your start print temp call that you need to do. Start print procedure call that you do as part of your G-code. This is the standard for what RatRig has initiated, and we covered this quite a few documents ago, or videos ago, so go and have a look at that when we started installing the software. Initially we only gave the extruder temp, which was the nozzle temperature, the bed temp, but now I've added one more parameter called chamber temp, which equals chamber temp equals the chamber temperature value, right? And the chamber temperature value comes from the type of filament that I'm setting. So if I go to the filament and I look, yeah, because this is a PLA, I've got a 0 value for the chamber heater. But as soon as I go and I select my ASA, you'll see I set my value to 55. So this value will go sit in that parameter. It'll be passed into chamber temp, right? So chamber temp, so it'll say chamber temp is equal to 55 inside the G code. The G code comes as when the print job starts. It comes in and it puts that chamber temp parameter into target, and it'll heat up to that value. Then I tell it for a temperature weight. I say to it, the sensor called heater generic chamber heater must wait until it hits a minimum of that temperature which we've set it to, right? And once it reaches that temperature, it can continue. Not very complicated, but if you've never done it before, it took a bit of time for me to figure this out because I kept putting the wrong temperature sensor here. I didn't realize you have to put in the full heater underscore generic chamber heater. I initially just had one of the sections in there. Yeah, I think just read online, look at a lot of documentation as to set that. But for the rest of this G code, I pretty much did nothing. I just changed these two lines. Okay, so now I've got a chamber heater running, and as part of my startup procedure, that chamber heater will warm up. Let's go to the vexing input shaper, right? Input shaper helps with compensating for the resonance in your printer. Now, as you're printing, it's shaking, right? And the head and the belt is also shaking. Now, you can imagine a piece of rubber belt can stretch. So when it stops, it doesn't stop dead, it stops, right? And that resonance causes artifacts on your prints, okay? So input shaping basically calculates what type of resonance is there in your machine and puts in a value that says, well, based on this calculation, I need you to stop in this way to combat that resonance, which will then take away things that we call ghosting, right? It's little lines and can I say, I don't even know how to describe ghosting. I could show you a picture, but I'm sure if you go 3D printing ghosting, you'll see what it is. It pretty much puts, you can see the letters or the words or the corner where it's had to stop. It actually runs through the flat surface a little bit. Now, for input shaping, it's pretty easy to run on the RatRig configuration. Basically, what you do is you're going to see inside your main screen, you've got some scripts, right? And here is measure core XY belt tension and generate shaper graphs. Now, one of the calibration things that I had to do with the printer was to measure the belt tension first. And I think what I'm going to do is I'll run it, but I'm not going to change the settings because I've now got the printer on a very wobbly table and on a swiveling platform. It's not going to be as accurate, but I will show you what it's going to do and what it generates. So if you give me a second, let me take my other let's pull this like that, and see if, let's see if I go to the side view. What does this one bring up? Ah, there you can see the actual print head. Now, the reason why it's wobbling has got nothing to do with the printer. It's because I've got a very, very flimsy camera stand. So excuse that for now. So I'm going to do a measure core XY belt tension, and then I'm going to show you the results of that. So you'll see, you might be able to see it, that the head is vibrating, right, and it's going left and right. And then maybe I should move this picture just a little bit this way for now. Can I? This one? Yes. Yeah, you see that the print is running through different frequencies, and inside my print head we've got the ADXL, what do you call it? Resonance measure device. I can't remember. I'm at a loss for words tonight. In any case, it's the ADXL measurer, right? And that's actually measuring the vibrations and calculating what happens when it asks the printer to do a certain vibration, what happens to the printer head. And it's testing it now at different frequencies. You might, if I take my speak closer to it, you might even hear it. Okay, so I hope you could hear that. So that's now busy measuring the vibrations. I just want to switch this camera off for now. We don't need it inside the screen. And what it's going to do is it's first going to measure X, and then it's going to measure Y in all the frequencies. So you'll see now it's at about 119, 120. I think it stops at about 130 something. I'm talking a correction. Gets pretty violent. Right. So now it's going to test the other belt. So it's tested one of the belts, now it's going to test the other belt. And this test pretty much helps us to be able to adjust our belts. But if you're going to do this test, please put your printer on a very stable platform and make sure you've got nothing loose lying around. Like I've got stuff on the top of the printer at this point in time, so I could be causing vibrations and things that don't make sense. But for demo purposes, that's fine. I'll show that now. Doesn't take too long to do that. It took me a little bit of time to get my belt tension correctly, because the graph that you'll see, and maybe, mind you, I can just open up one of the old graphs while this is happening so that you can see it. We go back to files and you go to oh, I deleted all those files. Okay, we'll have to wait for it and hopefully it'll work. What happened was I had a problem on my installation of RatOS. Somehow I went from a development version, a standard release version, over to a developer's version somehow, and I was getting a lot of problems, and that's where I had an argument with our RatOS friends and said, but I never asked to change. I've been doing everything according to the book. And eventually they realized that at a stage they had actually by accident moved or did some change that pushed anybody that did an update or a hard reset at that stage on their files from the standard edition to the developer edition, and that's why I was getting funny results. So I had to rebuild my whole machine from scratch, but it was really quick, very, very quick to rebuild it. I could have probably switched over manually if I wanted, but I thought it would be a better idea just to rebuild the OS, because I just copy the configuration across. Okay, it's busy generating those belt graphs now. Yeah, we've got from all the way from Chicago to Poland down to the Cape Point, South Africa, point of Africa, so, and the UAE in one call. That's really cool. So if you're on the stream and you haven't said hello yet, please do so. Just say hi so we can see where you're from, and then at the same time also, if you wouldn't mind liking and just hitting that subscribe button, that would help my channel a little bit further. Let's go to the menu. Alright, so here we can see it's created a folder called Input Shaper, and inside that it's created a graph called Belt Tension Resonance. And if we look at this, I'm not going to take this serious now. As I said, my printer's not on a very stable platform, but ideally what you want to do is get these two graphs pretty much aligned at the top points over here, right? The top belt and the bottom belt need to be aligned. So again, I probably have to do this again in any case when I put it onto the new back onto the table that's more stable and run it again, because I'm sure the belts stretch over time, and especially in the beginning, I think your belts will stretch more and more, and then they'll settle down. So at this point, it looks like my upper belt needs to be tightened a little bit more, but I'm not going to worry about that in this stream. But you get the point. Tighten your belts until those two are great. Don't over tighten your belts. Your frequency should be somewhere in the 40s, I think. I could be under correction. Maybe Matthias, you could confirm that. I can't remember. Or Jules, you've also got your printer. You can maybe confirm what the frequency was. I think it was around the 40 something. My belts might have slipped down in terms of tension a little bit over time. Okay, so once you've done that, then the next thing you're going to come and do is you're going to come back, and once you've got your belts tight, then you're going to do shaper graphs. And this is pretty much going to tell you a lot about, you can see it's shaking left and right again, the head. This is going to tell you now how to compensate for the belt's resonance in your, so that you can get rid of these artifacts. And again, this thing's going to run for quite some time now, and it's going to go through two cycles, one for the X and one for the Y, and then it's going to produce two graphs, an X graph and a Y graph. And also, if you want to know if your printer's actually got loose screws, anything in terms of loose screws, or your you've got a problem in terms of what do you call it, over tension somewhere, or you've got a loose bracket, Resonance is going to show you all of this very quickly. It'll also tell you sometimes, even if the loom cable, where the cable comes to the head, if that's pulling too tight, if there's a loose wire over there, it can pick up any resonance. So it's trying to test the head in the most ideal way to say, listen, you need to compensate for all these extra vibrations and head movements because of weight. When it's finished with that, it's going to come back and it's going to give us two more graphs that we're going to do. And once we've got those graphs, I will be able to show you how we get to these two values. Now, I'm not going to change these values again. As I said, I'm not on a very stable platform. In the meantime, maybe while we're waiting for that to happen, let me talk a little bit about the panels, putting the panels on my printer, some of the lessons I learned while putting the panels on. So I'm going to switch back to my main camera so that I can move around here and move one of my other cameras around quickly. Let's move this camera. Let's give it a bit more distance. Let's see if we can hit this side. All right, I'm going to move this camera up and down. So let's turn it there. Maybe I can move it just a bit more back. We can see a bit more of that. Right. So excuse the glare. You're going to see that the standard panels have one screw there, and then basically one there, and one there, one there, one there, one there, but they don't. And on the side here, they'll only have on this side, right? On this side, they'll only have one there, one there, one there. Now, what happened was when I tightened this panel and I pulled it against it, it's got this the sealant that's in there, and this sealant is sponge, which then squeezes, right? And it'll squeeze this, and it actually this polycarbonate sheet actually pulled into that soft sponge, right? Even though it's 1 millimeter thick. First of all, I tried to do 2 millimeters, but I thought I was going to be clever. Don't do it with 2 millimeters. It really doesn't work. Stick with the 1 millimeter sponge if you do order more. Because I didn't get enough with the printer, I had to order extra. But even so, when I used the 1 millimeter, there was a gap over here, and there was a gap over here, because these two screws were pulling it, and it was bowing around that. So I eventually went and I drilled extra holes in between to make the distance between these a little bit shorter and a little bit tighter, because I really wanted the seal. And I did that all over where the gap was too big. So down the bottom, that's extra, right? On the side, yeah, I printed two little brackets, one over there and one over there, to actually clamp and push it together. And then if you go to the top, we just do that. At the top, that one's extra and that one's extra. And I would recommend that you actually think about doing that from day one and buying the extra nuts and screws and just putting it all in and getting it over and done with, because you really want to have a good seal on that. That's the one thing that I learned on the panels. Further than that, panels were straightforward. Stick your tape on and tighten them in place. There was nothing funny. I printed these additional pieces. I don't know what they actually refer to them in the manuals called. It's under the accessories. And the reason why I printed them as well is because here where your panel meets the brackets, there's a small, like 1 millimeter gap that's open where the air can escape through. So these just help that extra little bit, and actually gives your machine a very good look and feel. So again, something I would recommend, just add it in from day one. Print those extra pieces and put them in so that you can create that seal a little bit better. Okay, let's come back to the screen. It has finished that resonance test, and you'll see it's now created two resonance files in the input shaper folder, one for Y and one for X. If we open this, you can see that my Y graph goes up nicely, and I've got a nice clean, clear cut graph coming through, which says to me that I've got nothing loose, I've got no strange artifacts or problems with my printer, which is a good thing. And you would see that the recommend shaper algorithm that they've given you is using ZV. So ZV at 35.2 Hertz with a maximum of acceleration of about 4,700. Now you need to remember that, because if you come back here, here's your, what were we busy with? X, Y, sorry. For Y, there's the number that you put in, and there's the algorithm. Now you'll see, but Raymond, you've got MZV, and over here they recommended ZV. Yes, that is true. Let's open up XGraph. Right, XGraph is recommending I use EI, and you can see that XGraph is not happy. But this has got a lot to do with my table and where the machine is at the moment. If I move it onto a solid platform, a lot of this disappears. And that's why I wouldn't trust it. But when I had everything on a solid table, it always came down to MZV, and I used that frequency, and I used the maximum acceleration. Now your acceleration on X will always be a lot more than Y. You've got to take the minimum out of the two. So in this case, if I was using MZV 12,200, and for Y 3,900, I would then set it at about 3,800 as maximum acceleration, and I would use that value. Right, so taking those values, coming back here, that's where those values come in, and then under your printer section, your maximum acceleration, remember this is set previously in the printer somewhere as a failsafe at a much higher value, but now I bring it into my user config section, my user override section, and I can set my maximum acceleration. Now my maximum acceleration with this machine on the side over there was at about 5,400, so I used 5,000 just as a measurement over there. It's very important to watch some videos on your input shaper and how to understand it. There's some very good videos out there to get a better and a clearer understanding as how that works. Right, so that's one of the calibrations. Then in terms of what else I did in the file was the maximum extruder value, cross section. When I printed this guy, I printed it with a 1.2 millimeter nozzle, and the width of the extrusion and the cross section is much higher than what you would expect on a 0.40 nozzle, which we normally print with. So I had to do this, but typically most people don't touch this because they print with 0.4. So you can, if you ever run into that problem, you will know why. It'll actually bring it up as an error. Chamber lights, yes, you will see I've got chamber lights in. Let me go back to a view like that and see if I can show you the chamber lights. Right, so chamber lights, side. Right, you'll see I've got chamber lights on the side here, running on both sides to give me a bit more clarity as to when printing, and it's just nice to see. I initially had the chamber lights at the top, meaning when I say at the top, I mean running on the rails over here and then shining down, but I had too much shadow underneath, so I brought them down and closer so that my camera would be above, and then I printed one or two of these light guards, and I'm still working on that design a little bit. I'm not totally convinced by the design that I have there at the moment, but if I go, let's say, to this view, when you go here, my chamber lights, I can adjust at what brightness I want them. And you'll see it'll go down, and there it'll go off. Alright. Now, I'm not sure if you're going to see it very well, but let me do this. Let's see. If I take this camera and I just bring it here in the middle for you, and I make it a bit bigger, you're going to see that there's this frequency oscillation on running over there, and you think, okay, so I've got a bad camera. It's actually not the bad camera. What happens is these lights, because I've only got them on now at 54%, it means it's switching on the light for 54% of the time, and it's switching it off for 46% of the time, right? So that on, off, on, off, on, off is actually creating that feel. It's so fast that your eye wouldn't pick it up normally, but a camera does. And so if I bring this up to 100%, you'll see that goes away a lot more. You'll hardly see it because the light is now pretty much permanently on. It's almost at the frequency of the camera can't pick up. Okay, it's just one of those things that you have to look at. So if I'm switching on my camera and I've got a camera installed at the top here, right, looking at the print, I need to make sure if I want to record that I'm actually going to put on 100% light. Otherwise, the footage isn't very good. Okay, so just a point to take note there. Right. What I want to do now is I want to show you the light that I've connected. I've connected that to a heater element. Right, so let's go back to here and we look at for pin PF9. You will see there's PF9, which is a heater element. Why am I using a heater element? I could possibly use one of the RGB lights, but because I'm running 4 sets of lights off the same connection, the heater element connectors over there and the way that those are configured, they can handle a lot more amperage, and so I'm not worried that I'm going to overheat the board or something by using, let's say for argument's sake, I use these 2 RGB connectors. I'm not worried that I'm going to damage these, and I can use these RGBs for later for anything else. But for my heater elements, I'm not going to use them for anything else, so I might as well use this to switch the lights on and off. Alright, and again, the same way that you were going to manage a heater, extruder heater, giving it 10% voltage, 30% voltage, it's a heater. A light's the same thing. It's just emitting light, but it's still a resistor that will be controlled based on the amount of voltage you give it. So using the heater element is just the easiest way of doing that in my case. It might not always be the same for every other printer, but in this case it was. And again, that's one of the reasons why I bought this Max EZ board, because, and the Octopus, the Octopus Pro board as well. Same with them. They've got all these additional connectors, and it gives you a lot of variation as to what you can connect, and you can connect it in many different ways. I've just used the heater element. Okay, let's come back to again I'm using pulse width modulation to control the light. Shutdown value when it's off is 0. Starts it. Cycle time, go and read up about that. Pretty much that's the default, and it can go up to 100%. So yeah, my lights were connected to the heater element. I installed a filament runout sensor right on the tool board, Remember, I'm using the EBB2 board, so if I go to this board over here, this one, let me just push Control here and zoom in a little bit. There is no direct filament runout sensor as such, right? But if you look at my configuration, I've said that I'm using the toolboard pin called PB3, right? And so on the toolboard head, I go here and I look for PB3. This I2C connector here in the middle can be used for multiple different things, right? And one of those is I've got my voltage, my ground, and my sensing pin on that filament runout sensor connected to there. I actually have PB4 connected to one more item. So on the Orbiter 2.0, on the filament sensor that you can run, and let me just do this quickly. Let's do that so that you can see. This is the filament runout sensor sitting on the top here, and you'll probably just get to see it. There's a green light there. This sensor has power to it, and it's actually got a button on the top here which you can push, and if you push that button you can actually run a macro that will load your filament and unload your filament. Now I'm not in the mood to really use that button because I feel I'm not going to get really all that much value out of it, because sometimes I'm going from PLA to ABS and from ABS back to PLA and then to PETG, and the temperature varies for every single one of those filaments. So what temperature would I set it to? I don't want to set it up to the maximum and then just change filaments, because then you actually burn some of the filament when it gets too hot inside the actual nozzle. So I've just decided not to use that button, although I could configure PB4 to do certain actions for me over there. I'm actually thinking of using that for something else, but I'll mention it in a later project. But PB3 is my trigger pin, so as soon as I run out of filament, and that's what I really like about the Orbiter, there's only like 1 centimeter above where it actually goes through the extruder. So unlike other filament sensors where it's much earlier and further down in the system, and you waste the last 100-200 millimeters of filament because it runs through the runout sensor, and the runout sensor says, oh, there's no more filament, and stops. This one waits right up until where the extruder is and where it goes into the extruder, and about about a centimeter and a half before it goes through the actual extruder. That's where it says, okay, now we've run out of filament, you have to change. So that's quite a nice feature about the Orbiter, which I like. So connected to PB3, my filament sensor is connected to PB3. We've already spoken about the chamber heater. I just created 2 macros, one for 100% lights off and lights on, because since we've discussed and shown, I have actually connected the clipper screen as well. So let me go just back to this view for 1 second, and I'm going to point this thing at my clipper screen. Let's see if I can get close enough to show you clipper screen. On a wobbly stand, so patience. Okay, so I need to go slightly up, right, like that. I hope you can see. There's clipper screen. This is a 5-inch screen that I got from BTT. It's a HDMI screen, so it uses HDMI connection directly to the Raspberry Pi. Okay, and it has also a USB connection from the side here that goes through to the back. I still need to sort out a feature to have these wires mounted, and I will do that later, but because I have got other plans to maybe extend the top of the printer, I haven't put those in as such yet, but I will make some channel system down the side. That's, as I said, directly connected to the printer, and over here I can now with this touchscreen control the printer. So the macros I created were inside here. Inside my macros I could come here and say lights off and lights on. Right, oops, lights on. Okay, and any other macros that are part of the normal setup I can run. This just gives me the ability to control the printer when I'm not in front of the PC. It also gives me the ability to do an emergency stop, which is sometimes needed because something's gone wrong with the print. Okay, swallowed my last bit of coffee quickly. So those are just two macros that I brought in. In terms of getting Clipper Screen running, stock standard, so already configured in RatOS. All you need to do is plug in the HDMI on the onto the Raspberry Pi. This is the HDMI cable coming through, and you need to plug it into the USB. I've got a hub. Remember, I've got a USB hub connected to this, one of the USB ports, and that's where your touch sense comes through and the power comes through for that little screen. Very simple, very easy. And that's it in terms of the additional configurations I made. I'm now thinking of whether we should, and I'm trying to look at the time. We've spent an hour and 10 minutes. So I want to think whether I actually want to now add the fan control for the bento filter, and I'm just trying to think what's the best way of handling that. Probably with a controller fan. But maybe not with a controller fan setting. Just for now, to test it, maybe I'll just use a normal fan setting. So if I go to my config references here, and I'll have a look on the side. Let's bring you into picture what I'm seeing. I'm looking for the different fan controls. Right, so here's fans, and I can probably use just a generic fan, or I can do a heater fan. And why I'm saying a heater fan is I can use the heater fan or 45 degrees because it's closed and it's probably printing something that needs to be heated, and therefore it's going to emit VOCs which we don't want. And so while the temperature of the chamber is hot, keep circulating, keep cleaning, and when the chamber eventually drops to below a certain temperature, it'll switch off that filter. That's one way of doing it. Another way of doing it is to just do a generic fan for now, manually controlled, and I can just switch it on and off until such time that I'm ready to actually incorporate it as part of my startup procedure. So Let's see. Just to get it, just to show you how this would work. I want to see what's the easiest way of doing this now. Maybe let's try and do this. Let's see if this will work. We'll try give it a quick 5 minutes, 10 minutes, and if we don't get it to work, then I will do it offline. Because I don't want to waste too much time. Because I actually want to show you a full cycle going through for the printing. Temperature fan, temperature triggered cooling fans. Whenever its associated center is above a set temperature, by default a temperature fan has a shutdown speed equal to max. Okay, I could also use a temperature fan. Probably that's what I will land up setting, but for now let's just do a generic fan. Let's just see if we can switch it on properly and switch it off properly, because that's the most important thing. The pin setting remains the same, it's just the control variable. Okay, let's take that, and we're going to come down here, and I always go down to wherever the next section is. And we're going to throw in that, and we're going to call this bento filter. Okay. To know what pin I'm going to be using on, I have to go back to my documentation. This one. I am connected to fan number 4, and as far as I know, PA1 is my controlling item there. Although I think I should have maybe moved my ground to PA1. Could be. I might have wired it incorrectly. Luckily it won't damage the fan or the board if it's wrong. So let's just go set that PA1. So pin is PA1. We don't have to worry about anything over here for now. Let's just save and restart and see if we get an error. Right, we don't get a fair error. Come to the dashboard. There's my bento filter. No fan coming on. Okay, so talking on the correction, I think I need to change 2 wires around. So let me just pull this up onto, yeah, and you can sort of see what I'm going to be doing. I'm going to pull this connector out, right, and I'm going to change thing. Please remember you've got AC in different parts of your machine, so be very careful where you put your hands, right? Pulling this connector off the fan connector won't cause any problem, but you don't want to plug a motor in and out while the board's on. A fan makes no difference. If you're not comfortable with it, rather just shut down, pull the power out. It's safer always. Right, don't do what I'm doing now if you're not comfortable with it. So I'm going to move this pin back. that one back. I'll put that one inside there. Basically what I'm doing now is swapping the positive and putting the positive wire back to where it was, and hopefully I've got it right in sense of this one I really had a problem getting in, and I think I'm going to have a problem getting it out now. Tyron, you still online? So the fans are running now, even though it's off, it's still running. So I think I'm going to have a problem with actually controlling the power like this. I'm probably going to have to connect it to a normal 2-pin power first, and then just use the taco pin for measurement later. Okay, I'm not going to worry about that now. Pretty much what I need to do, and I'll just show you, is instead of connecting to this fan 4, I'm going to connect it to fan 0 and just run my positive and negative there. That way I can switch the fan on and off, no problem. And if I want to read the taco speed, I can just connect it to this one pin just to see what it's doing. But I actually don't need the taco, so I will just connect those 2 pins over there. To do that, I need to cut off that connector, and I need to recrimp it to a smaller connector. So let's have a look. Do I have... I've got one of those here. Yes, I do. And I've got 2 of these pins. Yes, I do. Okay, move this a little bit away, and we can look. What's happening here? I'm going to use one of these little connectors. Trying to get it to focus, but it doesn't want to focus. Anyways, and these little pins. And question is, voltage, so the PA, the voltage, the red will be on the right hand side. Okay. Okay, so let me pull these connectors out for now. Unfortunately, I'm not coming right with the 4-fan connector. I probably could get it to work, I just need to work around it, but I really don't need it, so I'm really not going to struggle with it. It's just a waste of time trying to make that work for something that's not needed. Right. Get some cutters in my drawer here. some wire strippers, crimping tool. That one off. Cut that one off. Strip the end of that. Strip the end of that. Cool. Take my crimping tool. I can probably bring this a little bit closer so you can get a better view of what I'm doing. There we go. Why do you have to be so far? Okay. That's that one. After doing so many crumpings, it's actually, I haven't done it for such a while, I actually start missing it. Funny enough, you dread it in the beginning because it takes so much time, and eventually it's quite therapeutic. Okay, and if I have my calculations correct, this thing goes this way around. Okay, let's connect that just up to, we'll connect it to fan number 3, PA3. Let's see. No noise. Come back to the screen. Right, so I've connected it to that fan over there, PA3. Let's see if we go here. We go into here. And hopefully I'm going to get it right, and that you don't have to laugh at me. So this guy doesn't know what he's doing. PA3. Let's see what that does. Oh, PA3 would also need a jumper, because I need to set the voltage. And let's see. These are 24 volt fans, so I'll just look at the documentation quickly. Go back here. I don't know if I can see it there. V-in is the bottom connector. Okay. Where am I supposed to be? This one. So that jumper there puts me on 24 volts because my fans are 24 volts. Come back inside, yeah. I think I've already set and saved, correct? PA3, did I do it? Sure I did. Double check. PA3, save and start. Okay, dash. Right, working 100%. Okay. For interest's sake, I'm going to put my taco wire I'm going to put that one on there, and then if I go back to the documentation, I can see that PC3 should be my sense wire. Let's just see if I do that for PC3. Let's just see if I do that for a second, what's going to happen. Nice to play around. PC3. See if it gives me error. I'm not sure if you can do it like that, split it. Never really done it, but there's always a first for everything. Right, okay, yeah. So the Vento's 0 RPM. Yeah, there you go. Well, not quite. That's interesting. I go too fast and the RPM doesn't read anymore. I'll have to read up a little bit on why that is. Or is that now just a momentarial? Right, I'm faster than with the RPM and then. Huh. Okay, that's interesting. I'll have to go read up a little bit why it does that. But there I can see the speed on the fan as well. So I'm going to leave that like that for now. Switch that off, and I'll get back to the filter on that. I wanted to show you on the filter, and I think what I'm going to do is to do that I'm going to show you down the bottom here. So let me clean up some of these tools again, move some of these things out of the way. Don't need you, don't need you, don't need you, don't need you. Throw you in your way. I want to show you the cartridge system. And I should probably do this over something that I can mess on. Let's do on top of this. Alright, so we go back. Can we bring this down here? Yeah, we'll just do it over here. So I'm using activated carbon, a very clean carbon from a project called the Nevermore project. I know their carbon is very clean and there's no harmful stuff in it, and there's a whole technical write-up about this. Go and read up it, you can have a look, but make sure you use the right carbon. I'm just using the Nevermore carbon because it's much easier. So inside this housing, as I said, there's the HEPA filter inside there, right? And little magnets on the corners that hold everything together. Okay, magnets on both sides. You have to buy all those magnets as well. And then there's a cartridge, a activated carbon cartridge, and so the cartridge opens up like this. Inside there you've got these little cavities. These are little spaces that you print, gain magnets in place, and you might just see inside there at the back there's little notches. And what the idea of that is that you put this thing down level and you don't have to fill it to the brim, right? You fill it up until roughly those are full. If I can get the packet open, see, And by doing that, when it lies down, it covers sufficient amount of place for the filter to be full enough. So I'm just going to pour these inside here quickly. Okay, let's give or take, that should be fine. So, bring it up. That's what it looks like. Right. You want to focus with me? Okay, don't focus. Anyways. And I'm just going to take the cover. Slide it over there. Right. Give it just a bit of a shake to get it level. And this cartridge now slides inside here, so it's just easy to fill when you need to. You just take it off and come and refill it from that piece, throw away, put in. And then the carbon probably lasts. I've been using it for about 2-3 weeks at a time, and I've been printing a lot. So I think really it depends on how much you've printed, but there is a rule that pretty much says you need to change it after so many prints. But that's it. So I'm now going to put that inside here, and I'll just drop you down again. There was a harsh fall, and I'll just plug that in there, and in theory I've got a filter, so now I can print and I can filter the air. Okay, what I now want to do is I want to just screw this motor, this cover back on. Hopefully for one of the last times. There. Right. Oh, you can't see what I'm doing. That helps nothing. No. Table and zoom. No. That one. Or that one. At least you can see what I'm doing with there. Sorry. Let's screw this cover back on. Hello wife, thank you for dropping in. Thank you for the coffee just now, appreciate it as well. Okay, so that's connected. Now I'm going to go to a bit of a wider angle, zoom, and let's go there. And I'm going to now do what I've been wanting to do for quite some time. And you're going to have a little bit of patience with me because this is important. I'm now going to add all the little clips so that we can officially close the back end of this printer and say all the cable management and everything is now pretty much done. So let's see how quickly we can do this. And I'll start from the top. Yes, there are modifications going to come later on, but most of those modifications are more mechanical. Because I'm going to extend the top and I'm going to put in other extruders. I'm going to change it over to a multicolored printing machine, and that will come at a later stage. I really don't want to battle with that now, so let's just do that. You don't have to watch me like that the whole time. now that I'm seeing this PTFE tube, this blue tube over here, which is connected to my filament dryer, where I actually have the filament stay in while I'm printing, because I actually run the filament dryer sometimes while I'm printing. And also I have these filament dryers, they're from RatRig. They are to print dryers. So what I can do is I can control them via a smart app, and what's nice about that is I can set the schedule as to when I want them to dry, and I can actually activate them from the printer, which I haven't done yet. So those are also some of the modifications that I will do at a later stage, and that I'll bring into, so that everybody can see how that works. Why don't you want to go in? There we go. These screen wires I'm going to leave loose for now, until such times that I've decided what to do with the top, as I'm actually going to extend the whole top of the printer, and then I will hide those cables later on. For now, they're pretty much just going to hang around on the top of the printer until I've got a better plan with them. It's not the neatest, but at least it's out of my way for now. I might just cable them through a little bit later. I really wanted to do this as well prior to our home move coming next week. I don't want to have any cables come loose while we're moving around and carrying stuff around, so it's good that I'm getting this done now. And I'll also give you an idea as to what my whole intention was with. Okay, right, so that's the top row. There's lots of these little clips. I've had quite a few people ask me already for these designs. I think I have uploaded them to Printables on my Printables site account, so if you're looking for this, just drop me a message. You can grab it from the Printables. I actually think I might have created a link in one of my videos already to the Printables account, where you can see this whole design and print it for yourself. Makes quite a difference already. Don't know if Terry's still online. Terry, you busy doing models? Painting? Building? Quite a few of these. It actually takes quite a bit of printing to print all of these little things, but that's very nice. Very satisfying printing them, popping them off as you go along. Let me grab most of them out before I continue. Don't even know if I have enough to close the whole thing. Can you imagine I get to the end and I'm like one short? Let's hope that's not the case. Let's hope so. I'm a little bit worried that the black ones look too little. Hey, busy with the Buccaneer. I can put these covers also on because we are finished with them. These covers just cover the AC a little bit. Protect it from 1 or 2 fingers from coming in, hopefully. Not that any fingers are going to come close to this because it's normally against the wall and hidden away. Yeah, that looks like as many as what I have. I think when I'm moving to the new house, I must take on an easy project first. Maybe I must take on Terry's long overdue upgrade on his Prusa. Not too difficult. I don't want to get this in here. This one's going to be interesting to get in behind the Raspberry Pi. Well, there we go. Never say it won't go in. That's cool. We can do a combined shoot, Terry. We'll do a quick marathon, one night only upgrade. And then you can sell it and buy yourself a resin printer. Don't just say to anybody else I said that to you, but yeah. One of us need a resin printer. I've got the big printer. You buy the resin printer. Otherwise, we have to employ some of the other people that are keen. You know, those gaming. Yeah, those gaming guys. Maybe we can charge them exorbitant prices and we can pay for the resin printer very quickly. Here's an option, you know. Oh yeah, I was actually talking about the PTFE tube, this blue tube. So my idea was with the filament dryer to put the filament dryer on top of the machine and nice and far away, which is a good idea in general, right? But that means that the filament runs a long distance through the air and potentially picks up moisture on the way to the printer, one, or it's been lying outside the printer for such a long time because I haven't been printing. You know what I'm going to do, guys? I'm going to shut down this printer quickly. And the reason why I'm going to be shutting down is because over here I've got, although it's all pretty much covered, I do have AC down the bottom over here. And I don't feel like lighting up for you on my stream, so maybe it's just best I switch it off and pull out the AC plug. Okay, for those that are wondering if I did it. So with the filament tube, the PTFE tube, the tolerance inside the tube is built for actually, and this is a Capricorn tube. It's actually built for Bowden tube printers, meaning you don't want much play in the tube between the extruder and the extruder head, which is pretty much only, I'm gonna say, what, half a meter away from each other. So that tube never really needs to be that long, but I ordered like 3-meter long tubes, and after ordering the 3-meter long tubes and pushing the filament through, the drag on the filament is so much that there's no ways that the filament can run freely, and the extruder is working twice as hard to pull that filament through. And I first thought, well, I bought cheap filament, cheap Capri-Sun tubes or fakes, and so I bought directly from the manufacturer, and I bought long ones, and it was better. It definitely was better, but it still didn't quite work. And then I watched some guy, and he said, you know what, if you're running tubes from your filament holders to your extruder, why are you running such tight tolerance tubes? Because the tight tolerance tube is actually built so that you don't have movement of the filament on a Bowden extruder type printer. Why don't you buy a tube that's bigger in diameter, because you're not worried if there's play inside the tube. Meaning, if you take this tube and you're pushing filament through here, and it's going to do this inside. With this Capricorn, it's going directly through. There's no, the filament can't really bend, right? But because I'm pulling it with the extruder from the feeder, I don't have to worry about that. So I went and bought other tubing, right? It's the same outside diameter, but I don't think I can get to show you the it's never going to work. No, well, it's not. The inside diameter is where this is 1.9, 1.8 for a 1.75. This is closer to 2 point something millimeters on the inside, and the tube on this thing, which is close to, I think it's got an inside diameter of 3 millimeters, right? And this is 25 feet. I could push the filament all the way through without any hassles. I thought to myself, I mean, really, I've been such a stupid idiot for such a long time trying to find out better ways of getting better quality tubes, when all I need is a tube where the filament can run through easily without getting caught. And the easiest way of that is increasing the inside diameter, because I'm not worried about play. I'm pulling directly at the source and pushing into the extruder right there. So, because I've got a direct extruder. So yeah, that's one thing that I'm going to change. I'll change this in the next week or so, or when I get to the other house, I'll pull it out and change over to a bigger tube, which is then going to solve my problem of the filament being the extruder working twice as hard to actually pull the filament through. We're almost there. You might not be having fun watching me, but I'm having fun doing this. I'll let Terry answer that one. I think they are. I think all models are probably pretty much available. It's at a price. Yeah. Now I can't get this last one in. Yeah. Come on. Okay. Which side are you going? That side or that side? You're going that side. Let me just turn this printer a little bit this way for myself to work on a bit easier. Because these ones that I'm busy doing now are a little bit harder. Goodness gracious, come on. There we go. And from the filament drying perspective, I must say I've been printing now lately with a bit of eSun ASA. I can't say I'm an enormous fan of it. I think I really prefer printing with 3DO's ASA. Unfortunately, it's just very expensive for me to buy it and import it all the way here every time. It's become ridiculous to try and ship things to the UAE the whole time. And at some point you've got to think about, does it make sense spending that money on filament? You should be able to get it locally for cheaper. And unfortunately we don't have many options over here. I know my friend there in Poland has said to me I should come to him. He can give me some good prices from a company in Poland. Just need to see how to ship it, but I'll have a look at that at some stage as well when I get back into the new house and into the printing again. Almost there, almost there. Then my other computer just switched off with a sudden noise. I know, muddy. Well, what do you know? That's it. Have I missed anything? I have missed one. I have. One in the middle here. Let's see if we can keep that one like that. All done. All done, all done, all done. And there you have it. Wire management done. One of the things I really wanted to have as neat as possible, and I think I've done, from my opinion, a reasonably good job at wire management. I'm pretty happy with that. I'll switch these two on again. As I said, these two cables, I will sort them out when I fix the top. And this cable is going to become translucent, and there'll be guides taking. I'm actually looking at maybe somehow putting a shelf next to the printer with all the filament dryers on. So let me show you the filament dryer. I'll just bring it in here. Maybe I can even switch it on for you to just see where's the power for this one. I put it over here. Right. I need some power. Let's plug it in on this one here. Right. Plug it in the back here. Right. And so, thanks, Julia. That was my one design I really wanted to get right. Let's have a look at, if we look at the table main. Okay, so we've got a bit of a glare. If we turn like that, maybe we got less of a glare. Okay, so that's my filament dryer, and you can control it from the front screen, but what I'm going to show you is, if I hold that like that, can you see it? Yeah, you can probably see it. That's not too bad. I've got 3 of these dryers, and there's the RatRig dryer. If I click on it, I can now go into my filaments, and I can select my different filaments, and as I'm changing it, you'll see on the screen it'll set whatever, and I can set it to ABS and ASA, pretty much the same from a drying perspective. So it's gonna dry, its set value will be about 65 degrees Celsius, and it's going to dry for a time of 5 hours. I can now schedule it for later. I can tell it to start based on another trigger. It's like a home automation. You can program it. Yeah, we've got the LED lights, and you can choose your light settings, and you can have it flicker and whatever. I most of the time just switch the lights off. But if I wanted to start that now, I can just hit the start button, and you will see that the dryer will start accelerating the fan inside, and the heater will come on, and then it'll go. And so I'll be watching the humidity level inside there, and I will try and keep my humidity as low as possible. This is, as I said, connected not via Bluetooth. It is connected via Wi-Fi, so it's on the home network. So I can monitor this from wherever I am, and I can, if I decide I'm going to do a print job and I want to actually dry the filament up front before I get home, I can quickly connect to my home network, connect to the box, and then just set it for a time period, so that by the time I get home, the filament is pretty dry and ready to go. And yeah, and I can then also, if there's any problems, it'll let me know. It's got a safety mechanism that if you pick it up or you tilt it to certain angles, the dryer goes off. Other than that, nice little dryer. So if you're looking at buying yourself a dryer, it's one of the few dryers that can actually hit the 70 degrees Celsius mark. In actual fact, let me just stop it quickly. If you go to filament and you go to nylon, I think it is. Yeah, it hits 70, and it hits 70. It really gets to 70 degrees. I put in another sensor inside, and it's not just a cheap sensor that's trying to make you believe that it actually got to 70 degrees. It actually does get to the 70 degrees, but in this case it's going to go to 65 because I'm drying ABS. And then you can also, you've got two DIY settings, profiles which you can just set up for whatever you want. Yeah, I must say, nice dryer. Had a couple of issues. They were a Kickstarter program. I bought it off the Kickstarter. There were a couple of issues. One of the ribbon cables damaged. Sent the message to the guy. The guy said yes, it was a mistake on their side. What's your address? And they shipped me a thin little ribbon cable and the instructions how to replace it. Great kit, really well done. Really well done for a project. Well done in the sense of the support and also the product that actually hits the temperatures it said it will. I'm very impressed with this dryer. Okay, but I'm now going to pull it out because I want to actually show you the process of how my printer works now. So I'm going to put this thing back up the top here, and I'm going to try and untwist the Bowden tube, a little tube, because it's not the best way of doing that. And we're going to now, hopefully without dropping things off, turn the machine around. This is going to go past that. Yes, so let's just go to there. I'm going to swing this machine around. That's why I say it's not on a very stable platform. I can shake this whole table and this machine. And I want to get it up to there, give or take. And I want to zoom out a little bit. Maybe I can try and lift that camera slightly. Okay. Further to inside, nothing much has changed. I'm still planning on doing a bed modification where I'm going to bring in the smaller bed. If you will see one of my previous videos, I made the bed capable of unplugging. I'm going to put a smaller bed in, but let's get a print job started so that I can just show you the process that happens now when I close this up. All closed up with magnets, right? Sealed nicely, no issues on that. Unfortunately, you're going to see a bit of a glare. Nothing I can do about that, sorry. Let's see if we can zoom in just so that you can see the top end of the printer. Something like that. Okay. Okay, let's go to this screen, and you don't necessarily want to see that one. You want to see that camera. You're not really worried about which camera is that? That is the side cam. Let's switch the side cam off. Bring that there, and let's connect again. I'm not going to show you updates and things like that because I think I've shown enough times how to check for updates and things like that. What I'm going to do is I'm going to go here, and I'm going to turn this camera a little bit this way and come in a bit more. Yeah. and I'm going to start some form of print. So while we're here, let's have a look at, you need to do your temperature towers and your pressure advance tests. So let's do a pressure advance test that I can show you. This is a very important test that needs to be done. Beyond your once you've done your temperature and your flow rate, you need to do a pressure advance. But I want to do this so that you can actually see the print process as well. We have got eSun ASA printing there, so it's going to, because it's, no, I don't want to do a tower. Sorry guys, let me just go to new project and start that again. Discard all those settings. Remember, with the ASA, I've got the bed temperature to hit at least 55 degrees Celsius. Okay. I'm going to change this just to standard speed 0.6. I'll just do this, but I'll increase the speed a little bit so that we can get to the end of this. Let's make this a 80, 100. Let's make it 80. It's not going to be, I'm not normally with ASA I print a lot slower, but for this purposes I'll bump up the speed a little bit so we can just see the differences. Travel speed, let's make it up to 250. Okay. Calibration, pressure advance, we're going to do the pattern. Okay. Okay. If we then go to the preview, I don't like this new preview where they've put the G-code viewer on, so I switch that off a little bit. Bring that down. You're going to see that's what it's going to print. Right, it's a pressure advance test, and I'll explain how it works in a couple of minutes. And I'm going to hit print and upload. I'm not going to go further into things like this Orca slicer and super slicer. We've been through some of those things already. You've got to decide which slicer you want to use. I'm sticking to the new Orca slicer. I've come from super slicer, but I think the new Orca slicer is really great. So you can see the printer at the moment is doing a homing exercise where it did X and Y first. Right, and if I switch over to the device, so by the way, I can show you the camera as well. So that's the built-in cam. It's a camera that can heat temperature. What's happened now, after doing the homing, right, before it's going to do a bed level, it's going to heat the bed and heat the chamber, right, because things are going to move as it warms up. It'll expand and change a little bit, the dimensions and push things around. And so you actually want to do a bed level when the whole printer is at its maximum temperature and the bed's at the right temperature. So you might not be able to hear it. I'll come a bit closer. I'm not sure if you can hear that in any way. But both those heaters are running at this point in time, right? And you can see the chamber heaters going up and it's heading towards the 55 degrees. As I said initially, the hot air blows in at the bottom of the heater. So this bottom one shows a higher temperature until the top end of the chamber heats up. But we're worried about the temperature sensor, which is at the same level as the printer head, which is the top one. So that's what we're watching, that sensor there. In the meantime, the bed is also heating up, and I'll be honest with you, running the PTC heaters on its own without running the bed takes too long to heat up the chamber, just way too long. So you want to heat up the bed and the chamber at the same time, because this 115 degrees heated bed makes a big difference to achieve the chamber temperature that we need. Okay. Just there's the webcam from the inside. It's not the most elegant webcam, but it just gives me a view of what's happening if I need to look at the printer from a remote place as to what's happening on the bed and do I need to stop it. I will be connecting this printer eventually to Octa Everywhere or Octa Anywhere, and we'll take it from there and see if we can remotely connect and control the printer as and when it needs. It's also got that spaghetti detection in it, which helps. What else have I learned? Let's talk about, there will have to be one more video about the heated bed. Remember, I had a bit of problems with my heated bed. The actual bed seemed to be a little bit warped, and yes, it was. This bed is slightly warped, and RatRig acknowledged that it was out of their tolerance levels, and they have replaced it. The new heated bed is lying, and the bed is lying there. I will create a video at a later stage when I put that bed in. First thing that you need to do is put the bed in without the heater adhesive attached and without the magnet attached, and you have to scan that bed and see that your bed plate is as flat as possible, because RatRig will not replace your heated bed anymore if you've put the stickers on. I argued with them. Their documentation was wrong. Luckily, I had the video evidence. Now all their documentation is updated on the website. You've got no excuse. On the website it says, do not stick the magnet onto the bed, and don't stick the heater pad onto the bed until such time that you've done your first scan and you've measured the flatness of your plate, because if you do that afterwards, they will not compensate you for it. By doing that, also it helps also get your frame setting correctly. There's some amazing videos. You can go onto the RatRig forum on Discord. If you go and look at the mesh section in the RatRig, you will always see the same video gets repeated over and over and over, saying, watch this video and make sure you know how to fix your printer's setup according to your bed. So even though we measured it and we were as accurate as possible and we used engineering squares, we could be a millimeter out here or there. Understanding how your bed mesh is read and how to use that to determine whether your frame is square and correct is very, very, very important. And I've watched that video 100 times, and I actually had quite a few adjustments made to the frame, where I adjusted my frame just a little bit, and I'm talking minute fraction bits. I think I was using feeler gauges, and I actually at a stage where I was changing it by like 0.5 of a millimeter, moving the frame, and that made a world of difference to get my bed as flat as possible. But obviously I got to the point where I got it as flat as possible, but the bed was warped. So now next step is put the new bed in. Hopefully that one looks a bit better than this one, and I will then do all those settings one more time, and then once I've finished getting it as flat as possible and it's ready, and I'm happy that the plate that they've sent me is good, then only will I add the adhesive sticker, the heater pad and the magnetic sheet again stick it on, and then do my measurements from there. Remember, when you add that magnet, you could have deviation in the magnet not being flat, right? That's also possible. Your actual print surface might not be 100% correct, and so you can't hold RatRig responsible for the magnet and the print sheet being at these tolerances where we're talking about 0.1, 0.2 of a millimeter, right? You can't hold them accountable for those things, but at least they say they will be accountable for the bed, which they say they've got a tolerance of about 0.3 of a millimeter in terms of bed flatness, which is, I think, a fair measurement to go with. If you really want to go flatter than that, then order your bed from some of the other guys. There's a company in the US called Mandela Rose, and they have a tolerance acceptance, I think, of 0.1 of a millimeter, something like that. It's ridiculous, but their beds come at a hefty price. You're going to really pay for having that bed shipped to you, but if that's what you want, then go ahead. So we're at 54 degrees, right? We're almost there. You know, the little demo gods that want to always, Murphy, you know, he doesn't always let your demos work. Let's just hope he doesn't do it today. But I'm pretty confident we'll hit the 55. You can see it takes a little while to heat up the chamber. But this is fully automated, so I push the button, say print, and I leave, and I go to bed, or I go out for whatever I need, or carry on working. I don't watch it anymore, right? I'm pretty comfortable. All right, so it hit 55. Now it's going to do a homing exercise one more time because everything inside the printer is now warmed up. Okay. What it's now going to do is switch on. It's dropping the temperature down to 105 degrees. I heat it up to 115. I let it go up to 115. I think it's one of the settings, so that I can get the chamber heated up a little bit faster. Now the bed will just cool down. It'll wait for the bed to settle. I think my initial temp in my setup is here. I don't know what I did. $105, yeah. For some other reason, I can't remember how I got it to go to 115 first, and then it drops down to 105. Any guess? That's not important. That helps get the bed temperature up. So you'll see this is getting closer and closer to the 105 now. In the meantime, the heaters are still going, because when it hits about 57, I think the heaters will switch off. There you go, heaters just switched off. Now that temperature will start dropping. And in the beginning it drops faster than what it did it does after about a half an hour of printing, because the whole printer gets warm inside. So all the metal, aluminium, and everything starts retaining heat, and it drops temperature slower. So when it gets to 53, it's going to start up. Right there, the chamber heater came on. So it's trying to keep it in the region of about 55. In the meantime, the printer is now doing a bed leveling exercise where it goes to 3 corners. Why is this camera not doing anything? Seems like my Sony camera has gone and switched off. Well, that's interesting. Why did my Sony camera switch off? Ah. Seems like unfortunately guys, the battery went flat on my camera. So for now, let's see if we can move something around here. We'll just what I'll do is I'll take my other camera, bring it to the side. Okay, so it's busy with the bed level at the moment. Let's switch on the side cam and switch off the Sony cam, and you can just see it from the side for now. So since I've hit print, I've done nothing now. It's done everything by itself. It's doing the whole bed leveling. It's now done the whole mesh leveling. Right. It's happy. Now it's going to the back and it's going to get the extruder up to the temperature that it needs to print, which is gets there pretty fast because it's the Revo's new 60-watt heater. It gets there a lot quicker. It's happy with the chamber temperature at this point in time. And what it's going to do, going to go to the corner. It's going to do its blob, which you now can't see that nicely with that camera angle. But it's going to do a priming blob, which I've shown in the past, to prime the nozzle. And as soon as it's finished with the priming blob, it's going to start the print. Now it's a long process to start up, but because everything's automated, I'm not doing anything. It's all fully automated, so I can just push the print button and I go. And I don't mind doing this whole bed mesh and leveling and everything for every single print because I don't have to do it. It's all automated. And I know that at least then the heat map is being done properly. Let's see. Ooh, look at that heat map. That is really not nice. It's all over the show. But I think it's because I've been moving things around, so I've got to fix this as well. Let me see, what's the 0.4? Yeah. You see, that's, if you see, this is the problem I had with this bed from RatRig, and that's why they eventually replaced it, is because of this very bad warping that it has. But in any case, that will be fixed when I get through to the new one lying on the other side. While that's printing, I don't know if we're going to be able to see the quality on it, but let's have a look. We go over here. January. And we go to that's the printing. Forget about those two little dots over there, because those are me with my super glue fingers touching the print job, which was stupid, and I got stuck to my own print job. But that's the quality printing we're getting out of here, and then it's really neat. The white on top of this is a bit of bed adhesive that I use. I just wash it off. I should have washed it off before I took the photos. There you go. So the quality of the prints we're getting out is very good. These little tufts at the top are actually part of the print. Really nice. Just to show you what the different lights will make in terms of camera. The cameras are now compensating for the light by itself. But if I bring the light, turn the light up, you'll see all of a sudden they will have to compensate for that. From the front, it's very easy now to see the print job, but from the side, yeah, it's not that great. Let's see if we bring this one in from this table. Let's see if we hold it like that. Very difficult to hold this camera still. So I think that's pretty much all I'm going to cover in the build series. I'm again open to questions and on the chats. People can ask me questions there. People are approaching me on the website directly. Some people are approaching me on Discord directly. Happy to help and comment where I can. I think this has been quite a long build. It's been a very exciting build. Yes, I've done quite a few customizations. It took me a lot longer than what a standard RatRig build would take, but it's because I put the extra effort into all the wiring. Would I do it again? Yes, I prefer the wiring the way it is. I like my printer the way it is. Is it necessary? No, you don't have to do it this way. You can do a much easier wiring setup, and it should take you probably maybe a third to almost a half less of the time than what I took to build. But again, remember, you're not building a RatRig, you're building your RatRig. Same as they say with the Voron, you're not building a Voron, you're building your Voron. It's a nice comment the Voron guys have, and I think that's the important thing. When you decide to build a printer, please build it the way you want it, and decide how much effort and how much time you want to put into all the parts. I can go to town now. I can change all the plastic printed parts. Many of the plastic printed parts I can change to CNC aluminium parts if I wanted. There's special vibration damper stuff in. Again, the guys are printing high speed. I'm not too worried about high speed printing. I'm more worried about size and accuracy. So I'm comfortable to print slowly as long as I get the size that I want. And yeah, I also want to, at a later stage, put in 2-3 more printer heads, so that I can do a four color print. That will be a project maybe towards the later half of this year, middle to later half of this year, that I'm looking at, of which one of the filaments that I want to print is a dissolvable print filament, because sometimes you need to do print jobs where you can't get the supports out, and the best way is just to print with a dissolvable support filament, so that afterwards you take your part, dump it into some water, and the supports just dissolve away. That's definitely what I'm going to be looking at later this year. Yeah, and then hopefully with my website and things that have come up now, we'll grab some more business and start doing some more exciting stuff, some more designs for clients, and we'll see where this goes. From a streaming perspective, as I said, I will probably do a updated on the bed leveling at some stage, one video on that, and I've got a Voron that I need to rebuild, and I've got a couple of custom projects that I will do over the next couple of months. So I'll just stream different things at different times, depending on what I'm doing, and if I find anything interesting to stream, I will ad hoc create a live stream. Planning on doing a little bit more recordings offline, and maybe just doing some editing and then just posting them on the website for those that are interested. So do keep watching on the on the YouTube channel for a while, and you'll see that I will bring some extra stuff in over there. I think we don't have to wait for this print. You know, you've now seen enough of this printer printing. The Pressure Advance is an important print, something that you need to do, but that's well documented. I don't have to teach people how to do the Pressure Advance, but just to recap, make sure you've got your belt tensions right, which I now see I need to redo. Get your resonance right. Make sure the input shape is set up. Then do your temperature test. Then do your flow test. Once you finish your flow test, do your Pressure Advance test. Once you've done all of those things, you're ready to go. Remember, every time you change your filament, you're going to have to go back and do your temperature, your flow, and your Pressure Advance. Each filament needs to have that configured, and that's why inside my Orca slicer, if I can get back to the Orca slicer, yes, that's why inside my Orca slicer, if you go to prepared, you'll see I've got different profiles for each print, for each type of filament. So this is an eSun ASA. That's with a 0.4 nozzle, that's with a 0.6 nozzle at a 0.2 layer height. PETG at 1.2 millimeter nozzle with a 0.9 millimeter layer height. Yeah, and so on and so forth. You go through my print speeds. I'm very cautious on my print speeds. I like slower print speeds, but you need to play with those. And always start from the base, the standards, and use their configuration. They've done a lot of work on their printers. And yeah, that's about it. I want to thank everybody that supported me through the build. I want to thank everybody for joining from time to time, the positive comments, the suggestions, and yeah, I look forward to some more live streams later on in the year. For now, we're going to focus on some just offline videos, and then hopefully we can build it from there. But my channel is always open for questions, so please do ask questions. Get people to subscribe if you can. Ask them to like my videos, and thank you very much. Until we see each other again, cheers for now.